I am from Data Platform. I'm a product manager. My name is Udagawa. In this session, I would like to talk about Line in-house data catalog. Largely, I would like to talk about three themes. One is the introduction of a data catalog. Second is the motivation and benefit for in-house data catalog. And last but not least, we'd like to talk about how we develop the data catalog. In terms of the audience that we're expecting, in this session, mainly those people are interested in operating data catalog and those who are developing data catalog would be the target audience. So in terms of operation and development of data catalog, I hope this will be giving you some kind of an insight. Today's agenda, first of all, we'd like to talk about the overview of our data platform. And then I'd like to also talk about the backdrop, how we have decided to create the data catalog in-house, and the general data catalog introduction, what are the issues that we confronted, and how we have come about in the development of our data catalog. And also I would like to summarize our talk and also foreseeing our future work. So now I would like to introduce our data platform. The Line Data Platform have various applications, generating data, collecting them, and also processing and analyzing and visualizing them. It's an end-to-end platform. The open source big data ecosystem, on top of that, we offer our own proprietary tool. So Line employees will be able to utilize data effectively and safely. So that's how we have been able to structure this data platform. And our data platform, in terms of the size of the usage of a data platform, on the Hive table, we have over 40,000. HDFS size is over 400 petabyte, and also the jobs are over 150,000 jobs daily are being executed. In utilizing the data platform, I'd like to introduce some of the users. In Line, always data-driven is our guidelines for action. So in terms of, regardless of the job description, it's important that we make our decision based on data. So therefore, data scientists, these experts outside of the expert, we have back-end engineer and also other server-side engineer as well. So back-end engineer, in terms of utilizing Oasis as a BI tool, with a planner, we establish a KPI of the product and they monitor the KPI. And these users utilizing the data, some necessary tasks need to be encompassed. Executing query and getting output, we are going to familiarize ourselves with the data that you might be used, and then find the data, understand the data, get permission, plan, and also execute the queries. So in these processes, the users, in terms of data that they use, they need to understand the data more effectively. So which table is going to be more important, and finding the table and the data that you have identified, does that match with your objective? Is it the newest data? You need to confirm that. And afterwards, in terms of the column of the data and understanding the generation of data, we find the owner of the data and we get the approval of the utilization of the data, and we will be able to start to do our work and tasks. As I've said, in utilizing the data, it's important that we collect a lot of information. So collecting all this information and data users to be supported, we have the in-house data catalog, which have come to be developed in Line. The data democratization is the objective in utilizing data. Necessary data are being offered in a bulk or lump sum. So why is it so that we have decided to make our data catalog in-house? Off-the-shelf product, there are some product with utilizing off-the-shelf product. In order to solve this, what kind of data catalogs have been created is something that I would like to describe here. So there are two major issues that we have confronted. One is from the data source, collecting metadata, and the other is that collected data meta, how you be able to share them. So first of all, the metadata. Upon the collection of the metadata, we had some issues that we confronted. In terms of commercial data collection for metadata, there are three things. One is that many data sources, the metadata have to be collected. And the second is the data platform. There are a lot of overload and also the noise on the metadata as well. So I would like to take one by one. First of all, many data sources, the metadata will be collected, and that is very difficult to do. So as I've been described at the beginning, data platform users the data experts and non-experts. There are various users of the data. So self-service wise, they are utilizing the data platform. So therefore, the users then themselves, for me to be able to utilize the data effectively, it is important that the metadata, in order to enhance understanding, is going to be the vital source. So in realizing that, the data platform, with internal tools, there are over 10 components that data needs to be collected from. So in terms of the commercial catalog, introducing of that, in the in-house catalog, there are a lot of components where data needs to be aggregated. We need to involve a lot of different departments, and system and API needs to be developed. And also maintenance work is also essential. So therefore, it was not practical to introduce off-the-shelf product. The second issue is that our data platform, every day we have 150,000 jobs that are running. And also it's a significant impact that leads to this outcome of our business. So therefore, on the data platform, we need to make sure that we guarantee stable operation. So upon collecting metadata on the metadata platform, it was a big concern that overloading the data platform is a concern. And also general data catalog, in getting in the table, through all the table, we run the queries appropriately. And in terms of introducing the commercial catalog, it's the same. Hive data warehouse, all the table on the warehouse, we need to execute the queries. But the data platform, there are already 40,000 tables residing. And depending on the table, on ARI, there are partitions that are generated, and we have exponential amount of table and partition. So therefore, the general data catalog available at the time of the query that I implemented for data collection is too much of a overload. And that is going to be a very serious concern on a data platform. And also, in terms of our environment, without the overload, aggregation of the data, and at the same time, we need to get the newest metadata possible, because one data are being utilized by multiple users. That is the reason why we need to get the latest information, especially DDL on the table. We need to offer the latest information available. Last but not least, on the metadata, there's issue about the noise. In our environment, in a few minutes, there are 500 to 300 to 500 data that are subject to change. So for the user, metadata that's meaningful have to be collected and also changed accordingly. But unfortunately, just collecting and aggregating data, many noises. In other words, for the user, non-valuable data are included. So there are some examples of the noises that we have seen. First of all, the user error manipulation was leading to the metadata generation. The user had, as an error, created a table and deleted them immediately. In these cases, normally, that table generation and delete information is going to be stored and is going to be displayed on the catalog. And other noises I also like to introduce. The DDL changes. The DDL changes also are being conducted frequently, but all the DDL changes for the users, are they useful? No, not necessarily so. For instance, the timestamp changes also are going to be detected as DDL change, and that is going to be aggregated. These information to reflect on the catalog, on the data catalog, there are too many information, and it is very difficult for the users to utilize them effectively. So therefore, aggregating the metadata, not just collecting and aggregating them, but you have to be a valuable data for the users. So only necessary useful data have to be collected. So far, in terms of the commercial data catalog, collecting metadata, we have confronted these problems. So from here onwards, we have to, I would like to share with you some of our approach moving forward. For us, there are a lot of issues, and these are the approaches that we have taken. The multiple data sources, collecting data, some of the issues on the data platform, the component and efficiencies need to be linked effectively, and we decided to collect data effectively. And also on the data platform, not too much overload, but the newest data needs to be obtained. Apache Atlas notification are utilized. On a push basis, we decided to collect data. And last but not least, on the metadata, in order to reduce noise, there are two major approaches that has been implemented, and the data changes. Every 30 minutes, we have aggregated them, and also the logic that we utilize on the metadata, we could do filtering. So we like to go one by one. So first of all, the various components, how data are being collected, I would like to explain.
So what you see here is the whole picture of a data catalog. On the far left, you see the major data sources for the data catalog. I'd like to simply explain an example of how data can be derived from data sources. Timestamp and Hive trends, these are obtained through Hive Data Warehouse. An access log to different data and query runs. Query will be parsed and aggregate, and as a result, we've been able to get information on queries. Now, let me describe the components that ingest metadata. We use Kafka and Airflow. If real-time data is required, it's ingested through Kafka. If not, it is ingested through Airflow. And then the ingested data is then stored in the databases of Apache Atlas and our data catalog. Finally, our data is authorization. It is managed by Apache Ranger through an internal workflow. System approval for the use of data has been obtained, and we collect this information and provide it in our catalog as metadata. So in this session today, we'll discuss how to get the metadata from various BI tools and also how to generate data lineage through Atlas. Starting with BI tool, how can we collect metadata from BI tools? I'd like to talk about how we can utilize the metadata that is collected. Starting with the functions. This is called report catalog. The function report catalog allows you to see at a glance which reports in Tableau and Oasis that are being used for a particular piece of data. From different perspectives, this is utilized in many ways, specifically for the purpose of data governance. It is possible to graph the usage status of each data in a report. And you can organize data. You can start with the reports that are utilized most. You can improve efficiency of your work. This way, we have created a system that allows you to monitor data usage in detail and organize data at any time. On the other hand, in terms of promoting data utilization, this function provides an image of how to use data. And because of this function, this allows the user to understand what kind of report will be affected by the data change. This is a specific data that is displayed. You can see the name of report in URL, and using users are described here. Let me introduce how this data is obtained. We have created a system that collects data from Tableau and Oasis in batches every few hours. For Oasis, it's an in-house tool. When retrieving metadata from Tableau, we use the metadata API provided by Tableau. The implementation method is as follows. From each BI tool, we use API to get metadata and then parse the query contained in a report using parsers such as Spark and Trino, and then linking each data and report this. So this function is enabled. Next, we are using Apache Atlas to collect data lineage. I will explain how this works, along with the functionality of data lineage. For those who do not know much about lineage, in a nutshell, lineage is a visualization of data generation. The purpose of developing this feature is really to be able to monitor the data generation process and users who are involved in this generation from the data governance perspective and from a data utilization promotion perspective. The purpose is to understand the data dependencies and the scope of impact of the data change and improve the efficiency of data debugging. So this is the data that is displayed on the data lineage. In actual work, when we figure out the dependencies of a table, depending on the security level of the table or a column, because the urgency of our work changes, we need to be able to check PII. And if there is any failure affecting other tables, it's necessary to be able to share that information. The users that are using this and the report that are affected should be confirmed immediately. So how can we obtain data lineage? let me talk about how we get the data lineage. In order to get data lineage, we introduce Apache Atlas. This is OS's data catalog, information that is changed through Hive. And the reason why I introduced the Atlas, there are several reasons. One is that we are using Ranger for privilege management, and we wanted to integrate Atlas and Ranger in the future. The other reason is that we received support from Cloudera in implementing Atlas. We also decided that Atlas is old and established and more stable than other tools, such as OpenLineage. So how Atlas can actually capture data change with Hive and generate lineage. Since Atlas supports Hive by default, it is possible to set up an Atlas hook on the Hive server to get lineage. The Atlas hook, when a query such as create table is executed, the changes are saved to Atlas via Kafka. Data catalog uses Atlas REST API to retrieve lineage. Next, I'd like to talk about the lineage generation, how we can get lineage generation by the changes made by Spark. On our platform, Spark is often used. Atlas, by default, did not collect data changes made by Spark. Therefore, by implementing the Spark connector developed by Cloudera, we are able to capture the lineage generated by Spark. The Spark connector allows the Spark driver and the hook module installed in the Hive data warehouse to send changes to Atlas through Kafka, and they are combined and registered as a lineage in Atlas. And then when we display lineage, we can combine the data we get from Atlas and combine that with information on data owners and PII. In other words, we do not simply display lineage from Atlas REST API. We aggregate data from other data sources to display lineage. And lineage UI is provided in Atlas. Combining this with collected information, we allow us to provide valuable functions to our users. So in this presentation, we have introduced report catalog and data lineage. The whole system works with a variety of data sources, as you can see, collecting a lot of different metadata. Now, without overloading the data platform, how can we collect up-to-date metadata? I talked about Atlas earlier. Atlas has a notification function. You utilize this function to collect data based with a push base. So let me talk about the Atlas notification function. As I explained earlier, Atlas hook and the changes made will be stored in Atlas via Kafka. Because Atlas is integrated with Kafka by default, when this is saved, Atlas hook consumer will send metadata changes with the Kafka topic named Atlas entities. By using this notification, data changes are immediately detected and the latest metadata can be obtained. The reason why I introduced the Atlas notification, I just want to introduce the reasons why. As we consider different approaches in order to get latest data, we considered the way to avoid sending unnecessary data. And Atlas should be the core component to collect metadata in the future. So we have to make sure that this system should be utilized on an ongoing basis. With other approaches, such as Hive Metastore, Event Listener, and Atlas REST API, we did not choose them because they were not suitable for our use cases. And because of the cost of implementation, we have also an in-house search function in our data catalog. Atlas notification is utilized already to update the index. Lastly, I want to talk about how we can possibly resolve noise problem in metadata.
In the metadata, I alluded to example where noises are included and the users have by mistake created the table but have deleted immediately. In these cases, for us, on the consumer side of Kafka, every 30 minutes we decided to aggregate them. So as an image, this is going to be the flow. The multiple work and tasks are being implemented, but it's going to be one consolidated notification. And it's going to be aggregated. And also at the time of aggregation, the Atlas notification content are being filtered. The data that's going to be collected every 30 minutes by aggregating them, the user in a minimum amount of time will be able to create and also delete table, and that is going to be judged as a error by the users, and that is going to be ignored. So this is a logic that we created. But on the other hand, if it exceeds 30 minutes, then as you can see on the second part of this chart, the information of generation and deletion also will be reflected and collected. So some of the data that being generated by the mistake and error users had been eliminated as much as possible. And also Atlas notification, partly there are redundant information. So we also have conducted filtering for that as well. So this is Atlas notification, the actual record. As you can see, looking inside the record, the table that have changed and also confirming the data after change could also be confirmed. I will not go into the detail today, but Atlas notification record could be monitored directly, and you'll be able to filter the duplicate data so that you'll be able to avoid aggregating unnecessary data. So the implementation is as such. Kafka Streams library are going to be imported, and then it could be aggregated. Code 41 to 43 line, as I've introduced, Atlas notification content and the several conditions, you'll be able to filter the notification, and on line 45, one single data, you'll be able to aggregate multiple changes, and on 46 line, we have the window set up for 30 minutes. And also, on top of this approach, we also have made a judgment whether the collection of DDL change needs to be subject to that. Again, looking into the content of Atlas notification, this is a number of the notification on the column that's being conducted on a voluntary basis. So we did not really know what the actual change was on the data. So the DDL change content, to understand that, we have to take a different approach. So the recent data metadata we have been storing on the data catalog on the database, but in terms of the Hive database, the DDL changes are going to be grasped based on the content of Hive DWH and the deletion data. And we analyze the change of DDL changes, and we have identified those that do not bring value to the users. So specifically, in terms of the content of the DDL changes, 95% of the time, it's only change of timestamps. So this change is going to be ignored, and that was built into the logic. So as I've said in the metadata, in approach to eliminate noises, in terms of before and after injection of Kafka, we have came up with several schemes. So far in a commercial data catalog, these are the problems we have confronted in collection, aggregating metadata. By overcoming that, how have we overcome them? By utilizing and establishing our own data catalog has been explained. So what are the benefits that have been attained through these efforts? First of all, the latest metadata from various data sources, we'll be able to collect them on a data platform without overloading them. And also the metadata, by filtering noises on the metadata, for the user, only meaningful metadata could be aggregated at the same time. And also, as a data catalog, what kind of value would we be able to offer to the users? We'd like to introduce some of the use cases here. As an example, analytics engineer for ETL have changed the DDL on the table and wanted to notify that to the other users. The users on the data catalog with the search features will find the subject data. And with the search, the finding and identifying the table ETL. In the detail screen of the table, we confirm there is a data that is going to be ETL, and also will confirm the utilization limit of this data. And the data lineage and report catalog with its processes, some of the table that is subject to be affected, and confirming the report. In executing ETL, we need to confirm there is no effect on the stakeholder, and by doing so, we execute the query. And with the execution of ETL, in notification to the stakeholder, this is also being supported in the data catalog. So the major communication tool inside the company is Slack. By utilizing Slack, all the content of the changes are notified to the stakeholders in our data catalog. The user's job are well supported. So this is the feedback from our users. So as you can see, by users, there are different feedbacks. But let's say analytics engineer's case, at the time of the change of the data, you on the fly be able to confirm some of the changes and the scope of changes. So it had led to the efficiency of the work. So those are the feedback. So in the data catalog, in collecting aggregated data, we were able to do so successfully so far. So now in terms of the OSS data catalog, commercial data catalog, what are the problems that we have seen in terms of the display of the data? Well, this time, to make the story more concrete, this is an issue when displaying metadata, utilizing Atlas, and also displaying lineage. We like to also focus on this specific use case. There are largely two issues that has been confronted. One is the issue related to Atlas performance. The other is related to usability. First of all, some of the information that you obtain from Atlas through API. What are the performance issues? So the performance issue we confronted is from Atlas, obtaining lineage through API in a specific table. You require 30 minutes to call on the API. There are two causes for that. One is the data generation, the table utilized for data generation. There are too many associated tables, so the node has increased quite extensively. The other is our data platform. Hourly, the jobs have been executed. Therefore, there are again additional nodes because of the hourly execution of the job. So in terms of the issue of multiple nodes on the lineage, how can we overcome this problem? In our data platform, a given, let's say, table have over 250 table generation. It was a source of the 250 table generation. So temporary table. There are unnecessary table that are also registered in Atlas. So exponential table and the lineage has been created, therefore. And followingly, in terms of the issue of the increase of the node as we execute the job, Hive and Spark processes. In other words, the query that has been executed, we are also collecting those information of the query execution. But the processing information, when the job is executed, is going to be generated one after another. Again, this is another reason why we are seeing an increase of the load on the lineage. And also, utilizing Atlas in displaying the lineage, the other issue is issue related to usability.
So this is the actual UI of Atlas. Even with such a complex lineage, Atlas REST API returns all the nodes from the very first access. It takes a long time to display it, and it's very difficult to see. Also, as you can see in this image, Atlas lineage is displayed directly in our catalog. Only the relationships between the tables, not only the relationship between the tables, but the relationship between columns are directly displayed. As you can see, Atlas UI provides more information than needed. It was difficult for some users to use. Now that we have covered some of the problems we faced in using Atlas to display lineage. Now I'd like to talk about how we can respond to these problems. Let us introduce our approaches. First, the problem of many nodes included in lineage. This was solved by filtering the data hooked in Atlas. And the problem of increasing the number of process nodes. Every time a job is executed, we can solve this by deleting the target process nodes periodically in Atlas. Lastly, in relation to the usability issue, by providing interactive UX, we are now able to meet a wide range of needs. So first of all, I will talk about the approach to reduce the number of nodes in lineage. Atlas has the ability to filter database tables according to the regular expression patterns. By utilizing this function, we're able to avoid hooking unnecessary tables in Atlas. Specifically speaking, we filtered template tables and those that are generated by employees' individual database, setting the conditions to patterns like this. We are able to set more granular settings, but in order to do this, we had to understand the naming conventions of individual databases and tables, which would increase maintenance costs over a long time. So we decided to limit the rules to this level. And then I'd like to talk about approaches to deal with the increasing number of nodes every time job is executed. Earlier, I mentioned how we apply filtering to avoid Atlas hooks. Even when we could filter the tables and databases, we could not filter the process. So as a result, unnecessary process nodes were generated every time a job is executed. Therefore, for unnecessary nodes registered in Atlas, we developed a batch to periodically delete them. Since some of these unnecessary processes could be divided into several patterns, we decided to directly eliminate and delete some of these patterns. Lastly, I want to talk about the usability issue in Atlas UI, how we solved them by providing UX. Let me talk about this UX. In our lineage, we can display up to 3 levels of nodes by default. This makes it easier and quicker to display and view even lineage with a large node. And if you want to see the lineage at the column level, you can select the column to see the table generated by that column. In addition, drag and drop, zoom in, zoom out are also supported to meet the various needs of users flexibly. Some of the problems of displaying lineage, I'd like to summarize some of the approaches we took. With these solutions, what kind of result have they brought to our data catalog? Atlas API response took up to 30 minutes initially. Now it is less than 6 seconds. And we can display such a large lineage in less than 15 seconds. Also, by implementing an interactive UI, UX, you can visualize the entire lineage and column level lineage. And we can now respond flexibly to various use cases. Now let me show you what kind of values we are able to provide depending on the use cases that we have. When you execute ETL, different columns require different security levels. We need to carefully check the scope of the impact. So checking the lineage on the column level will allow us to work safely. And these are some of the user feedbacks. I'd like to highlight some. They said we have received feedback from the analytics engineers and backend developers that when there is a delay in ingestion data, they are able to immediately identify the affected data and reports. And from the data governance perspective, they say it is now possible to monitor end-to-end the data generation process and the users that are involved in its generation. In addition, as a result of resolving the lineage issues that we faced, we were able to collaborate with Cloudera to contribute to the OSS as well. The part of my talk today is actually introduced in the tech blog as well. This time, we focused on the problems of displaying data lineage from Atlas. In displaying metadata this way, we have developed various innovations. Lastly, I want to summarize my presentation and also our future work. So this is a summary of my session. With the diverse users, there are many different users. In a self-service data platform, it is important for users to be able to leverage their own data. And we had to provide a variety of metadata so that they can better understand. So rather than collecting metadata blindly, it is important to apply tuning the metadata with use cases. In addition, as we create data catalog, OSS technology has been quite useful, but as I mentioned earlier, we had to make some adjustment to suit our environment. So introducing OSS, it is important to understand the needs of the users, and it is also important to understand our own data platform. Let me talk about our future work. There are three major areas. One is to use metadata for a wider range of purposes. On top of data platform, looking at the user's query result, we are able to generate a variety of statistics. Utilizing that information, we can apply that to cost optimization on the data platform. And secondly, to make the metadata available, referenceable on various tools. For example, when checking the data usage conditions, it is not easy, or it is a hassle to access the data catalog every time. We plan to make it possible for people to refer to metadata on a BI tool. And finally, it is to provide a more personalized data catalog. I did not explain today in this presentation, but data catalog should be able to provide personalized recommendations. By improving the accuracy of the recommendation, we can reduce the amount of time users spend searching for data, help them to spend more time on productive work. Thus, we will further promote data utilization through such initiatives in the future. This concludes my presentation. Thank you so much for listening.
宇田川さん、ありがとうございました。
Mr. Odagawa, thank you very much. So, from here onward, it's going to be a crosstalk, so there may be some questions from the viewers. So as much as possible, we would like to have a dialogue picking up on the question that has been presented. On the right bottom, there is a question mark button where you'll be able to post your questions. So the question is from Fukushi from Yahoo Japan. Could you introduce yourself? Yes, thank you very much. My name is Fukushi from Yahoo Japan. So I belong to Data Service Division, Data Group, Technology Group Manager. Thank you very much. Thank you very much. So Mr. Fukushi, listening to this session, what had stuck to you the most? Well, very meticulous detail. I think it was well presented. I know there were a lot of hardships, so I would like to congratulate for a good presentation. Data catalog is a very important tool, but again, it is not under a limelight. So therefore, I think that the effectiveness and utilization and benefit is very hard to verify. But in terms of KPI that you follow on the product, if you do have any, I would like to learn that from you. Thank you very much for the question. Yes, data catalog, at the end of the day, is utilizing the data, and you need to have some kind of a deliverable output, and it's a tool to support that effort. So how much you'll be able to make that process efficient is the KPI. So specifically, our data catalog, in terms of privilege management and other functions and features are available. So how many transactions were generated for the permission, and how many catalogs or how much has been viewed, those are our KPIs. Thank you very much. So, in other words, the utilization level is very important to measure them in a quantifiable manner. I see there are some questions from the viewers. So, in terms of data catalog, how many users are utilizing the data catalog, especially which functions or features are users? Can you answer this question?
So in terms of how much it is utilized, it may be hard to imagine. It will be about 3,000 people every month. They actually use this every month. In terms of functions, since there are many different functions, it depends on the users who use them. Lineage, report catalog, the things that I introduced today are very popular ones. Thank you very much. Listen to your presentation. Lineage information has been very well aggregated and collected. In terms of business metadata, do you also collect that data as well? Yes. Business metadata collection and aggregation, we've had a hard time. Yes, we are collecting that data. To be a little bit more specific, as I explained today, systems metadata and operations metadata, we are collecting a lot of them. What kind of data is utilized most? That's what we know. So especially when it's used frequently, depending on the order, we can actually establish business metadata.
So thank you very much. So you're collecting on the lineage. That is the reason why you know the importance of the metadata and you're focusing on these areas. Thank you for your answer. So in terms of permission management, I think it's quite well developed. And in terms of the data governance, data catalogs are very important in the neighboring countries as well. But it's very difficult to put that into implementation. So I think it's very well done, and I envy the outcome of this. But in terms of the data permission management, on the data catalog, everything is done on the data catalog, is that correct? Yes. On the data platform, the data authorization or permission management are done on this platform. I see. So then, for instance, the mid-hires, they can access the data catalog and they know the privilege or authorities that has been granted to the individual. So is that right? Right? Yes, that's the image. That's very correct. So our data catalog, the data permission management, outside of that, we create database and Jupyters, those notebook, also could be called upon and invoked. So those mid-hire, if you access this data catalog or data platform, on the utilizing data platform, all the necessary information could be obtained on our data catalog and platform. Thank you very much. Very, very beneficial and useful tool. Thank you.
So another question that I'd like to ask is about the future work, as you mentioned. You talked about the personalization. Can you be a little bit more specific in terms of personalization? What are you doing to personalize? We're collecting mainly users' history on catalog and query runs. Collect these information so that understanding what are the recently used data and frequently used data by users. We generate that data. So you look at the actual use in the past and predicting what kind of data a specific user would use. Yes, that's correct. So there is another question from a viewer. Grasping the initial need to the end of the development, how long did it take, the whole thing? And also paid solution, have you considered the paid solution? Was there a need? Was there not a need for a paid solution provision? With regard to paid solution, as I mentioned earlier, because of our environment, it was not easy to introduce that immediately. So that's why we developed in-house. In terms of the whole development duration, depending on the function, for each function, it usually ranges between 1 month and 3 months. For all the products, we started the development 1.5 or 2 years ago, and then we have been able to increase the number of functions we have developed. So it have taken 2 years, but it had a span of 3 months adding every function. What is the development organization? How many engineers do you have? Well, the overall, at the peak time, we have 15, a little bit more than 15 engineers. Many of the back-end engineers, 7 or 8, and front-end engineer, also 7 and 8, and QA, product manager. So that's the mix of the team. So it will be a quite large team. That is why the product has been organized. Yes, data catalog has many functions. It takes a lot of resources. And that's why we've been able to develop data catalog.
Thank you very much. So again, the data catalog. So companies, which feature do they first get a hands on for introducing their own in-house data catalog? The specific features. Rather than the feature in specific, it's really the end users who are going to be utilizing this data catalog is most important. For me, data scientists, machine learning engineers, those heavy data users generating deliverable, and somebody who's looking from the governance perspective. We wanted to create feature and functions for these audiences which was quite important for me. So the functions and features like lineage, for one thing, is a frequently utilized functions for these audiences. So that I think would be prioritized. Okay, thank you very much.